Hello there, welcome back. This is lesson 10 in our acid and base unit, which happens to be unit 10. Today's topic is titration. So there's a cool virtual lab that pairs along with this for this week, I believe. So for this video, you should be following along with the note sheet that says Titration Calculations. It looks like as of right now, there is nothing officially due tonight. Just make sure that you are following along with the calendar on the website. Just the days that these videos are made are not the day that you are watching. So let's jump into a quick review from last lesson where we talked about neutralization reactions. So this one says, it even tells you to use table K and L to help write the reactions. So K has your acids, L has your bases. So carbonic acid is H2CO3. Potassium hydroxide is KOH. So it's saying, okay, now write a balanced reaction using these two things. So H2CO3 and KOH, we know our two products will always be salt and water. When we break apart our acid, it's H and everything else. When we break apart our base, it's OH and everything else. Outside with outside, inside with inside. You get HOH from the outside group. And you have K and CO3 to make something out with. K has a +1 charge according to the periodic table. CO3 has a -2 charge according to the table E. It's a polyatomic ion. When you crisscross, you get K2CO3 as your salt. Now, it asks you to balance it. This is not balanced. We have two H's from our acid and only one there. So we need to put a 2 in front of our HOH. It also means now we have two OHs from our bases. So you need a 2 in front of KOH. And now everything looks balanced. And if you wanted to rewrite this to make it pretty, H2CO3 plus 2 KOH gives you K2CO3 plus 2 H2O. So if that still confuses you, go back to watch the last two videos on neutralization. Let's just quickly go through one more example. Phosphoric acid is H3PO4. Sodium hydroxide is NaOH. Again, don't memorize that. It's on table K and L. We're going to be making our two products. We get HOH from the outside group. Na is +1, PO4 is -3. Crisscross, you get Na3PO4. It is not balanced. You have 3 acid H's, so you need 3 over there. It means you have 3 OHs from your bases, so you need 3 bases. Now everything is balanced. If you wanted to rewrite this, it would be H3PO4 plus 3 NaOH gives you Na3PO4 plus 3 H2O. Okay, so jumping into types of acids and bases. Again, we're still talking about the Arrhenius theory, where acids give off H+, bases give off OH-, but we can even further classify them as names, further classify them with different names. So HCl, it gives off one H, one hydrogen. We say it's monoprotic. Remember, mono means one. Protic is talking about a proton. And then we said a few lessons ago, H+ is the same thing as a proton. So H2SO4 gives off 2 hydrogens, so we call it diprotic. Di means 2, protic means proton, so 2 protons. H3PO4 gives off 3 H's, so it's triprotic. And tri means 3, protic means proton, so 3 protons. And if we're going to look at bases, works the same way. NaOH gives off one hydroxide group, so hydroxide is that OH minus. And so we call it a mono, means 1. Hydroxy is talking about OH base, so a monohydroxy base. So moving forward, remember we talked about molarity when we talked about solutions. So the unit we did before thermochem, I believe. It was not too long ago. And we said molarity is on table T, but molarity, big M, was moles of stuff over liters of solution. So when we're talking about acids and bases, we talk about molarity a lot. So this symbol will be coming up a lot. So if we're talking about a 1 molar solution, so again we say molarity as molar with a big M. 1 molar solution of HCl gives off 1 moles of H plus per liter. If we have 2 molar solution of HCl, that means for every liter there are 2 moles of H plus being released. If we have 1 molar solution of H2SO4, so we have 2 H's, so for every liter you have 2 moles of H plus released. And if we have a 2 molar solution of H2SO4, you get that 2 times 2, and you have 4 moles of H plus being released. So if we take a quick second, you try this with bases. It should take you like 10 seconds. So here, the first example, 1 molar of NaOH gives you 1 mole of OH per liter. So it only gives off 1. 2 molar solution gives you 2 moles. 2 moles of calcium hydroxide with 2 OHs, you get 2 times 2, so that's 4 moles of OH per liter. So when we work through this calculation, because titration is a calculation, there's a way to kind of always make sure that you are taking this into account. Okay, so titration is used to find the molarity. Again, the concentration of an acid or a base. And the titration equation is on table T, so that's that last page in your reference table. Mava equals Mb Vb. So M is molarity, V is volume. A represents your acid, and B represents your base. So when you're doing this, whether it be on the virtual lab or just how this works in general, you're adding a specific amount of acid or base to an unknown concentration, and then when you have your indicators, a color change happens, and you're able to find that equivalence point, that neutralization point, when the pH is equal to 7. Again, we're going to be, when you do this in lab, you use acid-base indicators. Most of the time for titration, we use something called phenolphthalein. And the point of neutralization is the endpoint. So, your corny chem joke of the day. What did one titration say to the other? Let's meet at the endpoint. Ha 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 ha. Okay, so here's the equation again. Again, this comes straight from table T. Mava equals Mb Vb, where Ma is the molarity of the acid, Va is the volume of the acid, Mb is the molarity of the base, Vb is the volume of the base. So it's again how much H plus you release, how much OH you release, and then the volumes. So, sample question 1. So you always want to write your equation Mava equals Mb Vb. So whenever you have a math-based question, always list out what you have. So Ma, Va, and I like to write H plus. You'll see why shortly, or as we go through more questions. And then Mb Vb OH. When we talk about molarity, we have to take into account how many H's or OH's the acid or base releases. So reading through the question, what is the concentration So that is keyword for M, of a 30 milliliter sample of HCl. So this is your acid. So it means we're looking for Ma. Our volume is 30 milliliters. Can be neutralized by 50 mils of 1.2 molar solution of NaOH. So what I want you to put where it says H plus and OH minus, looking at your acid, how many H's are in that compound? The answer should be 1. So when looking at your base, how many OH's do you see? You should say 1. So this essentially goes back to the what we did when we first started. So a 2 molar solution, for example, of H2SO4 gives off 4 moles of that H plus. So taking this extra step in your calculation, make sure you're getting this right. So now all you have to do is plug in. You get Ma times 30 times 1 equals 1.2 times 50 times 1. You get 30 equals 60. To get Ma by itself, divide both sides by 30. Ma is a 2 molar solution. And that's it. Okay. Going over the next one. Again, we're going to be using the Mava equals Mb Vb equation. So list out what we have. Ma, Va, H plus, Mb Vb, OH minus. So in this example, adding H's and OH's will definitely come in handy. So how many milliliters? So we're looking for volume of 3 molar H2SO4. So this is your acid. So we're looking for volume. We're given 3.0 molar. And then our acid has 2 H's in it. And then the rest of the question are needed to neutralize 50 mils of 1.2 molar aluminum hydroxide. That is our base. And here we have 3 OH groups in that base. So when we do our math, we get 3 times Va times 2 gives you equals 1.2 times 50 times 3. So 6 Va equals 180. In order to get Va by itself, divide both sides by 6. The volume of your acid is equal to 30 milliliters. Now, if you did not take into account this step with the H's and OH's, your answer will be wrong. So just make sure you do take that extra step. Okay, with the remaining practice questions, if you want to now pause the video and try the 8 by yourself, go ahead. If you still want to go through a few more together, don't pause it yet. So, next question says, determine the concentration of H3PO4 if a 90 ml sample is neutralized by 30 mils of 0.9 molar CaOH. So, one of the hardest parts with these questions is figuring out what's the acid and what's the base. If you have tables L and K opened, then that makes your life a little bit easier. Again, this is our equation. Mava equals Mb Vb. If we label everything out like this, Mb Vb OH, that makes setup really easy. Determine the concentration of this is your acid, so we're looking for M. We know we have 90 milliliters of it, and in H3PO4 you have 3 H pluses. Looking at the remaining part of the question, we have 30 mils of a 0.9 molar solution of CaOH2, calcium hydroxide. So we have 2 OH groups that get released. When we plug this stuff in, we get Ma times 90 times 3, which is equal to 0.9 times 30 times 2. So again, just plugging in everything that we had. Then we get Ma times 270 equals 54. So just a step down. To get Ma by itself, divide both sides by 270. So the molarity of your acid, or the concentration of your acid, is 0.2 molar. And that is it. Okay, so that makes sense if we think about it, because the acid, because it gives off more H's, is stronger, so you need less of it to equalize out the weaker base. Number 2. First step should always be to list out what you know. Yes, it takes an extra few steps, but it makes your chances of getting these wrong a lot less. So, how much 6 molar HNO3, that's your acid. So we have 6 molar. So how much? We're looking for volume. And this acid gives off 1H. And then to neutralize 39 milliliters of a 2 molar solution of your base, which also gives off 1. So if the two things are both 1, you can just kind of ignore it and not put it in your final equation. But if you want to, it doesn't hurt. So if we plug stuff in, we get 6 times Va times 1 equals 2 times 39 times 1. We multiply, we get 6 Va equals 78. In order to get Va by itself, divide both sides by 6. So the volume of your acid is 13 milliliters. Okay. Number 3. Again, same protocol for every question. Label out everything. Mb Vb OH minus. Okay. How much? 3 molar NaOH, so that is our base. So we know we have 3.0 molar for our base. Our base gives off 1 OH. And we're looking for how much of that, so the volume of our base. To neutralize 30 mils, that goes our volume of our acid, a 0.75 molar solution, and our acid gives off 2 H's. So, if we plug stuff in, 0.75 times 30 times 2 equals 3 times Vb times 1. 45, do some math. 45 equals 3 times Vb. In order to get Vb by itself, divide both sides by 3. So the volume of your base is equal to 15 milliliters. Okay. I hope the more you do this, the way that I'm showing you, the easier it becomes as you move forward. So for number 4, we are going to start off the exact same way. Okay. What is the concentration of 20 mils of LiOH? So that is our base, which gives off 1 OH. You have 20 mils of it. It's asking you what is the concentration. So what is molarity? What is big M? It is neutralized by 60 mils of 4 molar HCl. So we have 6 milliliters of our acid. It's a 4 molar solution. And our acid gives off 1H. So again, if it's like this, we can just kind of ignore it. So in this example, I will ignore it. So we have 4 times 60 equals, again, our equation is Mava equals Mb Vb. Mb times 20. We do a little bit of math first. We get 240 equals 20 Mb. In order to get Mb by itself, divide both sides by 20, and you get Mb, so the molarity of your base, to be 12 molar. That is it. Okay, last 4 questions. Question 5. Again, we're still using the same equation as we've been using all day. And are we going to start something new and not write it down? Absolutely not. Label everything. Yes, this step is boring, but it helps with the questions. What is the concentration of 60 mils of H3PO4? So that is our acid. We're looking for concentration, so molarity. We know we have 60 mils of it, and that acid gives off 3 H's. It's being neutralized by 225 mils of a 2 molar solution of BaOH2. So we give off 2 OHs. And then, if we plug stuff in, Ma times 60 times 3 gives you equals 2 times 225 times 2. If we do some math, Ma times 180 gives you 900. In order to get Ma by itself, divide both sides by 180. So the molarity of your acid, the concentration of your acid, is 5 molar. That is it. So these questions really don't get any more difficult than that. The only way that these get difficult is if you have this step. But if you're used to doing this step each and every time, then this is as hard as it gets. So this is our equation. Label everything. Mb Vb OH. Okay. How much 2 molar HBr, so that is our acid. 2m, we're looking for volume. That acid gives off 1H. Is needed to neutralize 380, that's the amount of our base, mils of a very weak, very 0.1 molar solution of NH4OH. That gives off 1 OH. So we can just kind of ignore that. It's too green. So when we plug in, we get 2 times Va gives us 0.1 times 380. So if we do some math, we get 2Va equals 38. Divide both sides by 2. The volume of your acid is 19 milliliters. And that makes sense because our base is very, very, very weak. The lower the concentration, essentially the weaker the base is. And so you need a lot of base, only a little bit of acid to neutralize it. So having a much smaller volume makes sense in this example. Okay, number 7. Guess what? We're using the same I can't see what I'm writing. Equation we've been using. And we're going to list everything out for like the 500th time. Okay. So reading this, you have 50 mils of a 1 molar solution of H2SO4. That's our acid. So 1 molar, 50 mils of it gives off 2 H's. What is the volume of, so we're looking for Vb, a 0.5 molar solution of NaOH that gives off 1 OH group. Now that we have to plug everything in. So 1 times 50 times 2 equals 0.5 times Vb times 1. So if we do some math, we get 100 equals 0.5 times Vb. Divide both sides by 0.5. And when you plug it into a calculator, the volume of your base, is 200 milliliters. Okay. Last example is, again, same exact equation. We are going to list everything out. Mab Mb Vb OH. An acid has an H plus concentration of 0.1 molar. So that's that. And a volume of 100 milliliters. The volume of the base is 0.5 molar. Well, how much volume do you need? So it's not even really mentioned that we have H and OH, so you can kind of guess that it has one of each. But again, we don't even need to worry about it. Plug stuff in, you get 0.1 times 100 equals 0.5 times Vb. Do some math, you get 10 equals 0.5 Vb. Divide both sides by 0.5. The volume of your base is equal to 20 milliliters. And that is it. So, on that note, that is it for titration practice today. Tomorrow we're going to spend some time going over reading questions on this same topic. But on that note, have a wonderful day.